Hey everybody, welcome back to yet another Prefect Live. I'm here with Chuckles Norris, aka Charlie, our product marketing manager, and then Bill Palombi, head of product. Hey guys.
Hey everyone.
Hello.
Awesome.
Yeah.
Cool. I told you guys I'd start with a story. So again, sorry about last week. Last week, bandwidth issues. I'm back home. Everything was good. We're actually in the Seinfeld apartment right now, which is it's great to be here. Last week I was in Chicago. Sorry for the bandwidth issues. We're back. I think everything looks like it's going really smoothly, which is perfect. So my story, we were talking about public speaking before we went live, and I worked at IBM, and this was probably 2015 or so when I first got in. I was in sales at the time, and they were sending me to like conferences and stuff. And then finally, I went to a TDWI in Los Angeles, and they're like, "All right, this time you're going to give the sponsored keynote." There's like 3 sponsored keynotes. And I'm like, oh, okay. Oh, shoot. All right. So like being the young, dumb kid that I was, I wrote it down word for word what I was going to say, which is like first rule, like no rule of like giving speeches or anything like that. So I write it all down. I've got it on note cards. I'm like, I can flip through. I'm up the night before, just like so nervous trying to memorize this whole thing. Everyone gives their talks. It's all going great. They're just like, oh, hey, our company does this. You can learn about us here. I get up there and I'm like, IBM, and then I can't talk. I couldn't finish. So I got out like probably 25 words, and then I just walked off the stage and I went to the back. My boss who was there clapped me on the back and was like, it's going to be all right. And luckily I figured out, I've told this story before to people here. I figured out how to like speak in public. I start with jokes always, every time. But anyways, I thought you guys might enjoy that one. For anyone who's ever had to give a speech in public before, I empathize with you. It can be kind of hard. Cool. Okay, so little story time. I love to start with a little story time. Bill, you wrote an awesome article, and that's what we're here to talk about. Kind of the ideas. It was pretty good. Sorry, I don't want to pump you up too much. It was pretty good. It was called A Brief History of Dataflow Automation. I'm going to chuck it in the chat. I'll leave a link to it right now. There it is. So I guess, why'd you write this?
Well, and I make this explicit, I think, in the article. One of the ways you can understand where you're going is to understand a little bit about, where, I guess, tools like yours have been before, and in particular, how people have solved problems like the ones that you're solving before. Mm-hmm. Also, one of the reasons I wrote it is that, we work with a really wide range of users and customers, and we see a lot of different setups across those users and customers. And it's not, there's patterns. Companies that have been around longer tend to have different kinds of tools, different kinds of processes. So this was an attempt kind of first for myself, then for our team here at Prefect, and then eventually for folks out there in the world to kind of think about how this entire kind of problem space has evolved and how the solutions to address that problem have evolved themselves.
Yeah, that makes sense. I thought you were going to answer with because you asked me to. No, but that was I think perfect explanation. Like we were talking about before. So you said this to me. I don't want to butcher it, hopefully, but to think about scheduling and orchestration, right? Which I think orchestration stems from scheduling. If you just think everything is fancy cron, you have to think about where data transformations really, but data storage transformations are happening. Where are those things being executed? Where does it live? And so that's what I loved about this write-up is that it goes from, like, I think you start in the late 70s and really kind of informs what's happening in the database, data warehouse, and then as we get into the like 2010s, like data execution world, which to me is a very new thing, and that informs therefore the tools that have been made to keep up with it. And it kind of in a way feels like orchestration is the tail that is being wagged by the dog that is databases, right? Would you agree with that?
Yeah, I would say any sort of storage level technology, inclusive of databases. Okay. There's also kind of data lakes, which you can debate whether or not that fits the definition of a database. And then, also just files on people's individual machines. And then in addition, how storage interfaces with compute, which I think until the past decade or so, they tended to be much more tightly coupled, and now we see all different kinds of combinations of storage and compute.
Did Cron start on local machines, just coordinating local like repeated processes?
Yeah, so I'm not an expert on cron beyond the research that I did as part of this post.
That's too bad, because I actually had your title as cron expert right under you. So we'll take that down right away. Production will get to that. Sorry.
Enough where I should be an expert, but sadly I'm still one of those people that needs a cheat sheet to understand the schedule that I'm looking at. So I did find, I think, the introduction of cron, and I think it was a 1974 or 75 Unix manual. And it was a scheduler from the beginning, and its design has not really changed much at all in several decades. And I presume that it was running on a single computer, if only because networking was relatively rare at the time, and to the extent it was done, you certainly weren't passing meaningful kind of amounts of data over the network. That just wouldn't have been technically very feasible at the time. So yeah, I think I would assume that cron for at least the first decade was being used in the context of a single machine.
I mean, that makes sense. Now I'm looking back at it now. Yeah, you indeed start with cron, and then came the relational database. How many people here have actually written like a cron command? Raise your hand. You have, Charlie?
Yeah, but just like a lot of asterisks, right? Like trying to repeat something. Yeah, like I need to do something daily, just like stick 4 asterisks and like, let it go to town.
Right. So relational database comes, so I think, and again, using your crib notes, kind of trusting your crib notes too. So I could be saying something just wildly incorrect, right? But that was Oracle. I'm an IBM guy, so DB2, not maybe before. I'm not sure which came first, but just the original OG databases come. This is like the original. Nothing is new, by the way, right? It's like in we'll get to the 2010s, but the 2010s, everyone's like, oh, explosion of data, big data. Like there's so many things to do. We need Hadoop for this, blah, 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 right? But I'm sure people felt the same way with the OG database, I'm sure.
Totally. And, like you said, especially the historical parts of this, come with a caveat that, I wasn't around for all this, but the best way to find out that you're wrong is to put an answer out on the internet and just let the sea of people come and correct you. I did have a version of this that included Ingress, which was the kind of precursor to Postgres. And, open source fans will kind of, and perhaps I could have given those folks a nod. Open source fans would emphasize Ingress's role in adoption, and in particular in database innovation. You can make a pretty strong case that Ingress has been, one of the, was for its time, one of the most innovative databases.
I had no idea
that was adopted by Oracle, and now informs Postgres. I mean, one of the reasons. So we're big database fans here. Certainly, our CEO Jeremiah loves databases. I'm pretty sure Ingress was kind of the benevolent dictator of it for a while. Was Mike Stonebreaker, and like is a real big figure in the database community. I've watched some of his talks. Just a really interesting thinker.
So, how do databases and then later data warehouses? I guess it's important to note databases built around transactions, right? You want to be able to insert and update single records all the time, like all day, every day. As people start adopting these things, then the use cases that they're building kind of push the limits of databases. And then people all of a sudden they have a ton of data and they want to start analyzing it, looking at it. So that's to me what data warehouses, what really drove the creation of data warehouses, optimized for analytics, OLAP. You want to be able to do big selects instead of inserts or updates. Why? So I guess we covered that, right? Data warehouses, they exist. Why do those inform schedulers?
Yeah, just to kind of expand upon your earlier point. So I think most people, to the extent they're kind of familiar with different types of databases, especially if they kind of entered like the data management world as you and I did like 10 plus years ago, you might be familiar with the distinction between OLTP and OLAP, OLAP. And the both stand for online transaction processing and online analytical processing. And it used to be, and I think was probably until maybe some point in the 90s, that effectively all databases were transactional databases, which is to say that they were primarily about maintaining the integrity of individual reads and writes to the database. Yeah, and that juxtaposes the other use case, which is, okay, I have this database that I'm reading and writing to that does its job. Now I want to do some sort of computation that cuts across rows. Usually that's some sort of aggregation. So like, for instance, I have a database that is my point of sale system, and I want to sum up all my sales at the end of the day. If I have a really big sales database, that's a hard thing to do computationally in a database that's not well suited to the task. So yeah, enter OLAP, and there's all different kind of ways to do it. When I was first getting started, I was using SQL Server tooling, and there was this notion of a cube, which is effectively like, people try and visualize it. It's not literally like a table in 3 dimensions. It's more so a set of kind of pre-computed values that you're querying against.
I was an Essbase user at
IBM,
actually. Yeah, so at IBM, they were Oracle Essbase users. I think they started using Essbase before I think it was acquired by Oracle.
Sounds right.
Right. That seems like it's something that would happen, right?
Yeah.
And and we were using cubes, and eventually we moved into Cognos. But this was so funny. IBM, great company, but they definitely trailed their own technology internally, dogfooding it by 5+ years. So in like 2013, 2012, we were just getting onto Cognos, right? When at the time, like what Looker probably started around then, probably maybe even earlier than that, maybe like 2011.
Yeah, I don't know. I'd have to look it up. I would imagine Looker probably came about just after some of the big cloud data warehouses came out, because
that's true. That's true. Right. But yeah, I don't want to skip ahead. So we get to the data warehouse, right? Data warehouses built for analytics. Finally, people have built enough transactional systems to get enough data to maybe make some use out of it. They want to start aggregating and looking at collections of things. What is my average transaction value? Like something like you said. So we're here, let's call that early 2000s to like probably 2000 to 2009 or so. And that's like what we were describing earlier as really the on-premise physical data warehouse, some experience from me, Netezza, which was acquired by IBM in 2011, I think, but was started in like 2002 or 3, was a Postgres fork, actually. And what they did was they put FPGAs, field programmable gate arrays, these little devices on the hard drives that help to do some lower level calculations, basically stripping away data so that you wouldn't have to bring as much memory into RAM, right? To be able to do a select. So around that same time or a little after that, so they basically found a faster way to do a big select by putting these little devices on these hard drives. They actually were doing that until about 2020. Right now they don't do that anymore, but believe it or not, I think. But soon after,
there's a lot of on-premise data warehouses still out there.
Right. No, but I mean the FPGAs, right? The actual physical thing on the hard drive. Now they use like NVMe SSDs and stuff like that, like just for faster reads. But soon after, I think comes things like Vertica, I believe, right? And I think common databases, and I don't want to toot the IBM horn, but DB2 Blue was one of the first columnar databases. I think in like 05, 06 was when they first started coming out.
Interesting. The first one I remember like seeing and using was Cassandra, which was, I think, out of Facebook and notoriously difficult to manage. We ended up eventually moving away from Cassandra because it was so hard to manage. But yeah, I mean, I didn't work for a company that could afford Vertica. Vertica was like, I mean, probably what you're talking about, minimum hundreds of thousands of dollars. You're probably a Fortune 500 company. It's got a ton of RAM, right? Like dozens of gigabytes of RAM, I presume. And this is back in the 2000s when that was crazy expensive.
Yes. And you're right. It was dozens of gigabytes of RAM at the time for sure, because you need to fit the whole query in memory in order to be able to do something. So I think that we start to reach hardware constraints then. And this is when Hadoop came about. And I want funny note, Charlie, you'll love this too, is that we have an O'Reilly course out there that we taught about orchestration. And I bet you can't guess what the category is that O'Reilly puts orchestration in. It's Hadoop.
I totally believe it. I mean, all the initial orchestrators, they were all Hadoop based, or like things that people called orchestrators were or Hadoop based.
So now we can I think really finally get into the crux of like what is orchestration. But people go to Hadoop because of hardware constraints. They want to move to lower cost, like standardized off the rack servers. They want to be able to put a whole bunch of them out there and hopefully have some kind of technology that you can query across those things. And so I think, is it out of Google comes MapReduce?
Yeah, that's definitely. Yeah, and HDFS and a whole set of technologies. I do want to address, so yeah, you had transactional databases, usually one per application, though not necessarily. You get a data warehouse. You need something to move the data from the former to the latter. And there was a set of enterprise tools that users of Vertica and similar types of data warehouses would use, I keep using the past tense because I don't know why. I guess I'm just thinking of this as like an earlier time, but it's Informatica, which is still, of course, a very successful company, and I'm sure a very capable product. But yeah, there was these, again, on-premise tools that were built specifically for these ETL use cases. And the whole reason so ETL, as many of our people in our audience know, extract, transform, load. The reason the T was in the center there is because the data warehouse itself was not kind of, from processing perspective, capable enough to do those transformations in itself. So instead, you would transform the data in memory with appropriate server somewhere else, then write it to the warehouse in the schema that you wanted it to be. And that's actually, I don't know if there's a good way of measuring this. I imagine that's still the most common pattern, even though, of course, ELT is becoming way more popular, especially among, kind of more modern approaches to managing data.
I mean, this whole idea of, you're right. Like we live in this world, and a lot of our users probably live in this world where it's like, okay, we're going to use the latest technology. Prefect was founded in 2018, right? So we're going to use something that's relatively new. But absolutely, when I was a salesperson, I called on customers that were, it's like industrial companies, for example. A lot of industrial companies are still using Oracle databases and even using transactional databases effectively, or like a Postgres database to do analytics. They still are. So I think we should always remember to, you're right. We should just ground ourselves in terms of what are we actually talking about in terms of the entire market. If you had to venture a guess, what would you say? Right, percentage of people. Let's just keep it the ELT versus ETL paradigm, right?
Oh, people. So people or number of uses. So
good question.
Right, because I would imagine, generally speaking, that there might be more people doing ETL type operations.
Yeah.
There might be more ELT type jobs in that. First of all, if you are doing ETL, you're probably going to have a series of sources that feed into more or less a single sink, whereas you're going to have for ELT a bunch of discrete pipelines and then workflows that are on top of the database, or the data warehouse itself.
Yeah.
And I would also imagine that folks doing ELT are probably pulling data from a bunch of different SaaS apps. And there's just been this explosion of single purpose, narrow business applications from which data needs to be extracted. So I would just assume that there's probably more. Well, I wouldn't say I would assume. My hypothesis would be that there would be more ELT pipelines, but more people doing ETL building.
Interesting. So ETL tools come about because there are now connections that need to be made between more systems, primarily probably database to data warehouse, but also probably made up of some other, maybe database to database type of movement. There's some. Now we have CDPs, for example, reverse ETL tools to move data into specific applications. But this was probably happening too, and probably handled by similar tools in some way in the early mid 2000s, even mid 90s. Excuse me.
Yeah, totally. I think in many respects, I would say Fivetran is kind of a more modern Informatica, right? And that it has this really exceptionally well designed kind of GUI for pipelines, and Informatica is itself primarily a GUI first tool, though it has, I think, of course, Fivetran, facilities for kind of more code oriented workflows. I have not ever been a user of Informatica, so I don't know much about using it.
Charlie, have you used Informatica? I have not. No.
Nope.
No. So what about? I guess so. Why orchestration? Why is orchestration a thing? And I might be keep rein me in if I'm skipping ahead, but is it because of these ETL tools and you got to start scheduling these ETL tools, or is it something more than that?
Well, here again, language is a tricky thing, right? I'm sure people were probably using the word orchestration before Hadoop, but it definitely seems to me to be the case that it grew in popularity alongside and maybe even as a consequence of Hadoop, right? And as you said, Hadoop let folks use commodity storage and compute much more easily. The MapReduce paradigm was how things were done. MapReduce is good. It's not a full-on substitute for a proper data warehouse. So like, for instance, like the example I always come back to is, and Kevin may have used this in an earlier Prefect Live, but like if you want to compute the mean across like many different sets of storage or machines, that's pretty easy. Like you can just compute the mean on each individual machine and count up the number of rows and then do an average of averages. And there you go. Boom, you have your mean for the entire set. If you want to do the median, though, now it's a lot harder because you need to order everything across the entire set. So you would end up needing to create these incremental tables or something like that to be able to achieve that. And it's not just a median. There's lots of different things that fit this pattern.
Yeah.
And in particular, things that need to be transformed such that they land somewhere that they can be queried. So yeah, I think the one that was kind of most tightly coupled to Hadoop, and here again, this is a tool that I've never kind of been a user of, was Oozie. Oozie, in fact, I think was very direct about it being the orchestrator for Hadoop. And then all the other kind of major orchestrators that people still talk about, Luigi kind of positioned itself as being an orchestrator for Hadoop. Airflow, as we all know, was the kind of most recent and most successful of that generation of tools that came out between 2010 and 2015.
Certainly. And then at this time too, I think that Hadoop might have been even more successful if it weren't for the rise. I mean, AWS founded in 2006, but the rise and adoption of cloud services, which kind of, to me, I mean, there's still managed Hadoop services out there, but and I think you said this to me once, Bill, just like there's more Hadoop workload than like a variety of the tools that we might think of as the most popular modern data stack tools. There's a ton of Hadoop work still going on because of the rise of adoption around that, like 10 to 13, 2010, 2013, 14 time period. But then I think you start seeing people move to cloud services, and it's a lot easier to maybe incrementally adopt things like Redshift. And I guess Redshift was created around this time. So, we start seeing people move to cloud services. Does that drive even more orchestration adoption? Does it drive more orchestrators? And why might it do so? Why might it drive more orchestration tools or just more orchestration use cases?
Yeah, it's a good question. I don't remember saying that to you, but I do think it'd be interesting to read about that, right? Because Hadoop was really a set of things. There was like various query engines, right? Pig, Hive, I don't hear. Yeah, exactly. I don't hear about people using those anymore because there's better ways to do it. Like in particular, I think if you're gonna like query something over HDFS, you might use Presto nowadays. But as far as the storage goes, like it's not like HDFS is like radically worse than just putting everything in S3 buckets or Google Cloud Storage. So I would imagine, yeah, there's probably still a lot of data sitting in HDFS format.
Maybe I made that up too. It's always possible that I made that up.
Yeah, I don't know. Yeah, I think, and this is another thing that like it's just my memory and might be wrong. I think Redshift was probably the first like killer app from any cloud service. Like it was something that people started using the cloud for, or at least in my world, started using the cloud for. I wonder if there's kind of any other tools that were like that. But my impression was that Redshift was a big draw to get into cloud for people because you could afford to use Redshift. And as we established earlier, your alternative to something like Redshift was like hundreds of thousands of dollars to like,
right.
A Vertica or an SAP or somebody like that.
And I wonder if it was, so I would say maybe it was the killer second order
Yes.
application, right? Whereas it was EC2 and S3, of course, were the basic building blocks of something. But yeah, killer app for sure. It's like something that was built on EC2 and S3. I mean, talking about history, it all goes back to Ingress because Redshift is a fork of Postgres. I don't know if you know that, which is really funny.
Interesting.
Yeah, Redshift didn't have stored procedures until like 2018, 2019.
Yeah, it's wild. I mean, one of the reasons Redshift was so successful, because I think it came out at about the same time BigQuery did. But BigQuery didn't support SQL for a really long time, but Redshift was I think the first of the cloud data warehouses to support SQL, which is why it became more popular more quickly.
I had no idea about that, by the way.
Yeah.
Like, what would you query who would you query BigQuery with?
Well, and at the time, it wasn't obvious that SQL was the killer feature, right? Like there was a lot of talk about NoSQL. Like everybody had their own kind of query language. SQL is useful and like has really endured as the kind of the lingua franca of analytics. But that wasn't obvious, I think, to people in the mid 2010s.
Interesting. Was Cassandra is NoSQL as well, isn't it? Cassandra is columnar NoSQL, which is interesting.
Yeah, it's columnar.
But is it SQL or NoSQL interface?
Yeah, I think they have some sort of SQL engine now.
Okay.
So you probably could get most like some portion of SQL to work on Cassandra now.
Interesting.
But that I don't think that was true like when it came out, and certainly not what it was intended to support.
And what I was kind of fishing for, metaphorically speaking, was you have cloud services, those building blocks that you can create anything with, right? And I think that after Redshift came a bunch of other tools, not only Snowflake, which is one of the big dogs out there, but customer applications where data is going to live, right? I mean, you can even make the case for something like Salesforce, because it was a cloud first, a cloud services based application. A bunch of data lived in Salesforce. You needed to move something between Salesforce and something else, right? Would you agree?
Oh, definitely. No question about it.
Yeah,
I don't know what kind of the storage layer of Salesforce is, but yeah, I mean, in many respects, like Salesforce is the modern day. Well, I mean, Oracle is still Oracle, but like in many ways, Salesforce has like become the thing that they tried to kill, right? And they're this behemoth that just acquires companies and then stitches them together. Right? We may need to cut stuff out. I don't know.
No, that's fine. I think Salesforce would admit that about themselves now. To be clear, they had what was the marketing? They had a big marketing thing that I've read about. I can't remember, but it was like very aggressively like anti-Microsoft marketing.
Yeah, and anti-Oracle marketing.
Right, that's what it was. It was anti-Oracle marketing. Sorry.
Yeah, they had this infamous heaven and hell party in which there was a 2-tier party, and the first tier was hell, and it was meant to be on premise, and like they couldn't quite like say it was Oracle, but like it was all red. Right? It was heaven, right?
It's interesting.
Salesforce's logo used to literally be a cloud, like, and some people when they like think about cloud, they're still thinking about Salesforce, and it was like a not so subtle kind of analogy
that's pretty funny. No, but so that's just one example of like an application where data is going to become siloed in a way. So all of these tools, even beyond like Informatica, which may have been the first one, but Fivetran I think was 2012, right? Something like that's
okay. Yeah, I mean, Fivetran has been around a while and is really an enduring tool. And I think the most successful of that kind of, there was a whole generation of tools that were kind of built to do ELT type work. And I think, I don't know much about the specifics of like the commercials of these businesses, but it seems to me from like a mind share perspective that Fivetran is the most enduring of that generation of tools.
So now can we talk about orchestrators? When do orchestrators really become a thing?
Yeah. So I do think it's like with the kind of quote unquote, like big data era, right? That like is typified by this data lake format on top of Hadoop. So yeah, you have all these workloads, and you have to segment your computation into discrete steps with dependencies between them. So cron, if you want to just run a single thing on a schedule that doesn't have any dependencies on anything else, like gets the job done, plain and simple. But as soon as you have these kind of branching, error-prone, dependent series of steps, all of a sudden you really need something to manage that to stay sane. And that's generally speaking what orchestrators were and still are for. It's now the case that way of doing things, decomposing an entire workflow into discrete steps, making those steps individually retriable, and then managing dependencies across all of them. That's the kind of most general purpose and kind of most resilient way to kind of model a process. So that model that was built for this kind of Hadoop world is now, I think most people would agree, a layer that cuts across kind of most parts of the data management value chain, if you will.
That's where I think there might be just not a lot of background for some people who may be starting to look at using an orchestrator, is that idea of decomposing. This is very much a software engineering kind of idea, by the way, but decomposing a complex task into many, or complex process into many small steps, or what we call tasks, and then mapping out the dependencies for those, and then executing them in some way. I think that is, if you talk to someone who may not know what an orchestrator is, they'll be like, just do the thing, right? I have X, I have Y, I want the thing to happen between them, just do the thing. When that thing that happens between those two systems or something like that is quite complex and needs to be broken down into many steps.
Yeah, totally. I mean, that was my entry into orchestration. I didn't know what orchestration was, like as recently as, less than 10 years ago, probably about 8 years ago, when I had a kind of a single Python script. I was kicking off with cron on a single machine, and the team that I had built that for came to me and they were like, this is awesome. Like, we need more of this. So then I built a few more scripts that another team did. So next thing you know, I have like 10 scripts, and like I'm starting to bump up against memory constraints in the script machine. So I space them out. And then I have like repeated logic across all this, the Python script. So I break that out into its own script. And now all the rest of the scripts are dependent on this kind of like pre-processing step. And, next thing you know, it's a non-trivial kind of set of dependencies to think about. And you end up, Googling effectively to figure out how do people solve this problem. And you find your way. At the time, I found my way to Airflow. And I think probably today, still many people do.
Yeah, that's really interesting. So that was your first, Charlie. What was your first introduction to an orchestrator at all? And I'll admit, my first introduction to an orchestrator was probably Airflow, but in like 2020, 2021, and it was with customers who were just starting to use around then, 2020 or so, Airflow, and they're saying, oh, we have this Airflow developer, and we want them to be able to work with your database. At the time, I was working with what is the artist formerly known as Netezza, and we're like, we don't know what Airflow is. We have no idea. Were you ever an Airflow user?
Yeah, I would say that take a step back. I think my first introduction to the concept of orchestration probably didn't happen until I was looking into Prefect as a company, right, and really trying to understand what the value proposition.
Because it's really poorly defined, right? Like no one says it's like we're an orchestrator even.
Exactly, really. Right? And then all of a sudden you see like workflow orchestration and Dataflow automation, which I'm sure we'll get to in a little bit as well. But obviously, first introduction to Airflow was the same kind of same story as Bill here, which was just using it as a scheduler, right? Or using the way maybe he used cron, which, by the way, I'm just going to put it out there. I think you guys have a lot of experience with the newer tools, but I feel a little bit called out because I've used all of these older tools in my last job. You know what I mean? I'm like, we did a little bit of cron. We still had Pentao out there, like still using Hadoop with Impala, right? So I'm like, still out there, guys. Like, don't forget that there's a lot of history built on top of these tools.
Yeah. Large enterprises do truly drive. That's why I asked that workload question to you, Bill, is that large enterprises drive a ton of workload. Incredible, like can't wrap your head around it. Just an amount of data. Like when I was at the very end of my time at IBM, because you talked about dozens of gigabytes, they had systems with terabytes of RAM. And right? And you've got queries that span across petabytes. And so how do you can like, they would store it in a data lake. They would say, okay, we want to somehow query that by moving all of the data into this large appliance. And I was like, well, that query is not going to fit even. We got enough disk. We have petabytes of disk on there, but if you run a query and it's like broad enough, it's just not going to fit in RAM, and it's going to spool and take absolutely forever. So we ran into a lot of like, oh, my query is 3 hours. Do you know what the issue is? But yeah, that's really interesting. I guess that too, Charlie, your point, I knew it as a scheduler. I knew Airflow as a scheduler. And you have a hot take sometimes with, I mean, maybe Prefect is just fancy cron.
Yeah, I mean, in terms of, if I'm going to describe myself as coming from probably a data analyst background, like not a true data engineering, right? So I had to learn how to manipulate data specifically for like a data science-y type project where we needed to take raw data and transform it into features, right? That was a one-time ask. And so my intro into data engineering was simply to schedule this job. And so that was my one particular use case. But at the same time, I could see a path where if I continued on that technical path, and as you said, Bill, like maybe there was a little more complexity. And in my case, I needed to just backfill data in particular, and I had to play with that start date and Airflow. That can be kind of a pain in the butt. So that's where every time you add just like a little teensy bit of complexity, that's where it starts getting a little more interesting, right?
Yeah, and not to even downplay cron. Cron is still used, like you said, by itself, but also in conjunction with tools like Prefect today, because it's so familiar and stable. And the trope, I think, around that we're kind of making when we say that Prefect is just fancy cron is that it is really easy to, I think the use cases you're both talking about is this idea of incremental adoption that we've all three of us have talked about ad nauseum. But I think, Bill, your story is perfect. I'm running something on my computer and I'm doing it kind of just for myself. It's because someone asked me to do something. And then they say, this is great. Can you do it times 100? And then they say, can you handle this really large data set when you do it? And by the way, I need you to collaborate with someone on it. It's like, oh, all of a sudden I found myself in a place where cron isn't just going to cut it. I think that incremental adoption idea is something you don't always see when you're starting out with, any kind of script.
Definitely. Yeah. And Prefect 2 kind of very intentionally accommodates this incremental adoption. So you could, for instance, use Prefect 2 and use cron as your scheduler and benefit from all the other orchestration capabilities that Prefect 2 has. And, we want as much as possible for Prefect 2 to be as modular as possible, such that you can use just what you need at that time, and the tool can grow with you as your use case becomes more complex or potentially, more kind of data intensive.
And so let's get to the present day. I think incremental adoption kind of plays into this, by the way, and being an analyst kind of plays in this because, so Spark came about, started displacing Hadoop. Snowflake came about, is kind of competing with Databricks as they're trying to stake out their claim as one or the other. And maybe it was an article about Snowflake where I read about Hadoop being still such a large player here. But really, from like 2015 on, it's been sort of choose your battleground. What's interesting about both of those is that they're both trying to make it really easy for anyone to do a whole suite of data analysis, data engineering, data science type of tasks. They're both trying to do that for sure. And there has been, I think, while there's a ton of data scientists out there, people call themselves data scientists, there's been a general contraction relative to demand in the data labor market. And I think that's forced, like Charlie's story really resonates with me. It's forced analysts to upskill themselves in a way, to start having to adopt some technologies and fill that gap, just because there's such an explosion, again, in demand for labor resources. But bring us up to the current, right? So Spark, Snowflake, and then let's kind of sketch out where we are today, which I think you do fairly well. And then I'd love to talk about like what the heck is, what would be a good definition for data flow automation after we get to the current.
Yeah, and as you said, like about 5 years ago, another set of new technologies kind of has come out. I think depending on how you think about it, you could conceive of it as several new waves, or perhaps a single big wave of new tech, all kind of enabling closer to real-time operations. So yeah, in addition to Spark, which, as you said, has a lot of kind of similar, it's similar architecturally to the kind of Hadoop ecosystem. There's also Kafka, which is not an entirely new paradigm. Like you could compare it to like an enterprise service bus or kind of a simpler message queue. But regardless, Kafka has become kind of much more prominent as it relates to creating kind of more message queue oriented architectures.
And question for you on that. Sorry to cut you off, but is everything just moving towards streaming? Is everything just going to be streaming in 10 years? I know you've thought about this too. So
yeah, maybe. I mean, we'll see, right? I do think that it's always a question of trade-offs, right? And I think at the margin, if it's the same kind of degree of complexity and degree of maintenance and time to implement, then people, all else equal, will want their data to be more real time. There's no doubt in my mind about that. The question right now, and probably for the foreseeable future, let's call it 5 years, is going to be, what is the kind of additional kind of burden as it relates to complexity? I do think the cost challenge will be addressed. I think players like Confluent and others are working to address that. But the complexity piece is going to continue to be a challenge. And then, at some level, there's how these tools capture the mental model of the people that use them. I think a lot of people, when they think of data, they think of a table of data, right? Their kind of first introduction to data was probably a spreadsheet program like Excel. Databases you can think of as essentially a set of worksheets in Excel. And I think that's part of the reason for the success of tools like dbt, right? They allow people to kind of continue to think of their workflows in that way.
By the way, that's the only way I can think of anything is table. It's a Microsoft Access. I'm 13 years old and I'm using Microsoft Access to do a school project. That's how I can think of it. So absolutely,
yeah, and that's something that I think kind of more traditional data processing. So let's call it data warehouse processing. It's going to retain that advantage, that it's going to more closely map the mental model of the users, I think, for some time to come. Message queues are just a different thing, but definitely useful. And, I kind of mentioned earlier that kind of the value of orchestration is it's something that kind of interfaces with and cuts across all of these various kind of ways that data can manifest itself and data can be stored and processed. And, we are kind of agnostic to which of these other tools kind of rises and falls in prominence. Our intention is to enable working across all of these tools, whatever ones become more successful.
So, I've said a couple of times, kind of joking, but kind of not, scheduler, right? Scheduling is really, to me, the genesis of orchestration. And so if I were to say, this is for both of you and for me, I should probably know the answer. And we're really just you can kind of toss some ideas against the wall here, but how would orchestration be different from scheduling? And I think that we can now reference, because we've spent a good 45 minutes talking about the history of, right, particularly the history of the data landscape. What has changed in those that has resulted in the difference between orchestration and scheduling, and what are those differences? What would you say those are?
So I don't know.
It's a hard question, by the way. It's definitely a hard question. So I'm not saying this is easy or that we're going to be 100% right, but I think we can throw some ideas against the wall.
I think of orchestration as a set of capabilities of which scheduling is one, and robust scheduling at that. And that's why I say with Prefect 2, you can choose to use Prefect as your scheduler, and I do think we have certainly a better scheduler than cron. But you could also use cron and choose to use us for our other capabilities. So that's the way I think about it.
Interesting.
So it's interesting. I think that what we've been trying to position ourselves as a way to build, run, and monitor robust pipelines that you just said, but also at scale, right? So there's something about the at scale here where it's not just about the big data, but also the fact that workflows are a common part of the data practitioner's toolbox now. And we probably, for example, just like in programming, as we're learning from software engineering, as you said, don't want to be repeating all of these processes all the time. So we have this new rise of maybe like a data ops role whose job is maybe to make the data practitioner lives easier, right? By developing and using software development best practices, DevOps best practices, and using that little figure eight of monitoring, building, testing, deploying, but doing that within the data landscape as well, right?
It's really interesting, this idea of data moving towards the engineering landscape. And engineering, continuous delivery type of practices. That's really fascinating. But it's like the challenge, I guess, here is that I think it's kind of what I pointed to, and I may be over explaining, right? I can definitely try to put things in too neat of a box, but constrained supply of more technical labor means that maybe data analysts are going to try to start working with effectively accomplishing things with an orchestrator that they may have done if they had more experience in data engineering, for example. So yeah, I think that maybe to me, you have scheduling, like you said. We define ourselves as building, running, and monitoring. I like to say resilient, scalable. For now, pipelines. I think that broadly we can talk about more than just pipelines, like containers, microservices, stuff like that. Shoot, where was I going with that?
One thing that I think is neat about kind of data operations as kind of an increasingly popular concept, if you think about kind of the series of titles that have become like the subject of discussion and everyone's focus, the title, to my mind, that was kind of the first of these that kind of emerged, wasn't a popular title that became very popular, was data scientist, right?
Yeah.
Sometime around 2010, data scientist, there was literally an article that it was the sexiest job of the 21st century and all that stuff. And that was kind of the role that was closest to, if you think of data as a product, the end, or an analysis as a product, the end product, right? It's like, we want all these data scientists because we want all these great analytic models, whatever the case may be. And then, a generation of data scientists get hired and they find that, okay, well, the data is not in sufficient condition for me to be able to do my job. So now I need to kind of do all this stuff that I actually isn't fun relative to kind of what I thought I was going to be doing. And eventually another title kind of emerges circa 2015, data engineer, right? And that kind of is meant to encompass the series of steps to get data in a condition to be analyzed or to be leveraged for any creation of business value. It doesn't have to be an analysis. And I think there was literally an article that maybe Maxime wrote that was the rise of the data engineer, right? So, and now I think the data engineers are encountering a series of challenges that they didn't think they were hired to solve, and they don't really feel comfortable with, and they would quite like to have a set of enabling people and tools. And to me, that's data operations, right? So it's all the things that are preconditions for being able to do data engineering successfully. So inclusive of getting your infrastructure correct, inclusive of sufficient permissioning of data, I think is increasingly a challenge as the kind of legislative environment gets, or the policy environment rather, gets more complex. And that's where, people, when they talk about data ops, they talk about like, is it a special case of DevOps where we just use DevOps tools for, data engineering purposes, or is it really its own thing? And that kind of access control, I think, is one example of which, it might end up being its own thing, right? There's entire companies now kind of, building tools to control access to data, for instance, like at the row level across whatever data stores that you have. Like that's an example where, DevOps wouldn't necessarily be as concerned with that type of problem.
Interesting. Yeah. So what I was trying to say when I kind of lost my train of thought was, I think in some way is the ability to like provision infrastructure in the context of your data processing, a feature of Prefect, right? Or in some way support for the ability to provision a variety of different types of infrastructure, like a Kubernetes pod, or like even just a vanilla EC2 instance, or Fargate, or whatever Azure's compute is called, right? Is that just one part of the feature set of Prefect, which would be, if we're going to go cumulative, scheduling, the ability to deploy infrastructure. What would be some others? Maybe parameterization is one maybe lower level interesting feature description of Prefect.
Yeah, totally.
Yeah. Cool. All right. Well, this has been illuminating and interesting. The data ops thing is really interesting, for sure. Like, is this the next role? And I know we've got analytics engineer. out there, but that feels like it's closer to the analyst, right? It's like the in between the data science and the data scientist and the data engineer is like this analytics engineer role has evolved. Maybe between DevOps and data engineer, there's a new role here that we call data ops or something.
Yeah.
You heard it here first. All right. Any last coining of terms? Do you want to coin this role as anything?
Oh no, I mean, I think there's already too many terms. If I could, I would start to simplify terms.
Yeah.
And that gets me to Dataflow automation, right? We published this post under that moniker rather than for instance, orchestration, or a term that other people might be familiar with. And that's in part to convey that we really do see ourselves as kind of relevant and useful in all of these paradigms. And that's the type of product we're building is one in which you can bridge gaps between tools in these paradigms and between the paradigms themselves. So anyway, that's the thought I would leave everybody with.
Yeah, that makes a lot of sense. All right. Well, thank you both really for coming on. I know that being live can be really challenging, and we're just kind of throwing stuff against the wall here. So I really appreciate both the thoughtful ideas that you guys are both bringing, as well as your willingness just to endure me for, it looks like 53 minutes so far. So really appreciate it. We'll talk to you guys soon. Thanks, guys.